Hi everyone, and welcome to Epsagon webinar, Serverless Monitoring in Practice. In the following webinar, we are going to discuss about the best practices in monitoring and troubleshooting serverless application. I'm going to guide you through. I'm Ribenzaft, the co-founder and CTO at Epsagon, and together with me, Gal.
Hi, I'm Gal. I'm a senior engineer here at Epsagon, and I've been with the team for the last year.
Perfect. So let's get started. Let's start with the first meaning of serverless. What is serverless? So we're talking serverless about the broader term. It starts with the compute part, the function as a service, AWS Lambda, and other resources as well. And we want to focus that serverless is much broader term that includes also our cloud resources, message queues, storage, databases, and so on, and also our REST APIs that we're utilizing as part of our application. Now we need to make sure that when we going serverless, the main thing that we want to accomplish is don't manage our infrastructure and focus more on our business logic. So focus on what we do our best. Now in function as a service, new limitations has been introduced. First of all is the limited runtime. So now we need to understand how long do our function as a service can run. Also in terms of memory, so we need to understand how much memory will our function consume. The next thing is stateless, so our functions are ephemeral, so it means that we need to interact with more resources to save our state and go pick on again afterwards. And also cold start that do introduce some performance implications as part of our applications. Now our applications are no more just a single compute unit. They compose with lots and lots of resources and APIs, such as S3 and DynamoDB and API Gateway, and also external resources, for example, MongoDB, Twilio, Stripe, and so on. And it's part of our application, which turn our applications to be highly distributed, and everything is event-driven. So it's really hard to understand what's going on in such complex system. Now let's have an example of HSBC from the latest reInvent in 2018. You can see an application that composed very neatly with all of the services. Each service includes its communication inbound and outbound, its own database, and all of these services are talking to each other, which makes it much more complex to troubleshoot and monitor. Is everything okay? Is everything talking properly one to another? Now, in general, in serverless, the monitoring challenges are that we've got no access to the underlying infrastructure, so we can't log in anymore to the database or compute unit and start debugging in production what's going on because it's ephemeral, as we know. We also need to troubleshoot now asynchronous transaction, which is much more complex because one thing happened at a single point of time and the other one at another point of time in a different environment, and now correlating between them is very hard. We also got unpredictable cost that we will dive into afterwards, but it makes cost much more of a problem than before. And as we saw, we've got some new compute limitations that haven't been before. So let's go one by one, and let's start with tracking the system health. And what does it mean to have a system in serverless?
So the first question we have to ask ourselves is, what is our system, right? In order to be able to track the health of our system, we gotta understand what is our system. And the first answer that comes to mind is that it's just a list of our functions. If you monitor all of our functions, all of our function in our AWS account, we will be able to understand the behavior of our system. But let's have a look at this example. In this example, we can see that our application is not made just by our functions. Our functions are an integral part of our system. Maybe it's our entire compute, but we have a lot of other resources. We have a DynamoDB table, we have an S3, we have an SNS topic, and we gotta monitor all of them too if we want our system to be resilient.
And on top of that, we sometimes got, like we see here, external resources such as Auth0, Azure Functions, and MongoDB, and Redis, and so on. It's the key crucial thing to monitor them as well because they're an integral part of your application.
Yeah, I think the thing is here is it's not just about monitoring your AWS infrastructure, it's about monitoring your application.
Exactly.
So maybe some of it is in Azure, you're still gonna wanna be able to monitor it.
Exactly.
Another thing is that you can't monitor a specific function or a specific execution because events in your systems are made of a bunch of executions that are put together. So you want to be able to track an event that entered your system through all of the components it went through, all of the different lambdas it invoked, all of the different tables or S3 items that it touched, and be able to understand each and every one of them. Now, this is a common problem.
So you're fundamentally saying that looking at each and every resource individually won't give me the bigger picture, or won't be able to distribute the trace between them or a thing like that, right?
Exactly. Now it's not it's a new problem, right? Distributed tracing has been around for as long as distributed systems exist, and the concept has been always been the same. We have a distributed compute unit, whether it's lambdas or just regular servers, and you want to take traces from each and every one of them and piece them together into a bigger transaction.
Yeah, transaction equals a story ultimately, because it's
it's just the story of the event through your system, right? Which resources it touched and what actions it took. And you can see this transaction. For example, here is a distributed tracing engine called Jaeger, which is open source. And when you have a visualization of these transactions, all of the different events, right? You can see in the timeline all the different events and operations that took place. You have a much better understanding of your system.
And performance. I mean, you can see how long each and every operation took across your distributed architecture rather than each resource individually.
Exactly. Now, when we talk about implementing distributed tracing, you can always do it yourself. There are a lot of standards. There's open tracing, there's open census. You can just hop into your code, and before every API call you make, just type, I'm making this API call, send it to the distributed tracing engine like Jaeger, and problem solved, right? You have distributed tracing, you have a good understanding of your system. But it sounds a bit problematic, right? That's a lot of code to write.
Yeah, lots of maintenance, and there's potential for errors in that. I mean,
someone forgetting to trace an API that fails.
Exactly, and honestly, in serverless, we're talking about the development velocity, and we don't want to keep maintaining things all over the place, and we want something automated.
Yeah, that's the point of serverless, right? Just focus on your business logic.
Exactly. Now, the second or the third thing that we'd like to talk about is the cost. Well, we said that in serverless, predicting cost is very hard, and it makes sense because, let's start with we're paying by the usage that we're doing. So, for example, the amount of requests that we're making, or the amount of time that we're consuming, how much compute resource have we utilized. And to some extent, it makes sense to pay per use. But actually, in real life, it's very different than that, because you don't pay per use for your gym, or your shoes, or your meals. You pay upfront about what you're going to take, which is similar to VMs, but in serverless you pay only for the amount that you're using. So it's very hard to calculate it. And if you look at some examples, for example, my favorite ones, API Gateway, Lambda functions, and DynamoDB. Yeah, so you start with Lambda, which is gigabyte seconds, which, okay, I can calculate how much memory do I consume, multiplying the amount of time that I'm using it. So, okay, API Gateway now is its request and data, the amount of requests that I'm getting, and the amount of data or the payload in each and every request. But now comes the Dynamo, which is how much data do I store, but it's also...
so how can you know how much data you're going to get, right?
Yeah, and read capacity units, write capacity units, all doesn't make sense. The calculation is impossible. I mean, you can't predict or even calculate, even when you know what's going on, to understand how much you'll pay by the end of the month. Now, in serverless, it's important to understand that performance equals times equals money. So time equals money is no new to any one of you, I guess. But in serverless, performance means time, and it means that performance equals our money, or the cost that we're about to pay. Now, in serverless specifically, we need to understand how much will we pay, or where do we spend our time. I mean, where do our calculation ends up? Is it more about our own code, our own calculations, or external API calls? And think about it. In serverless, you gotta have API calls because it's ephemeral. You need to store something in the database. You need to do anything external to that. So
also, that's part of the philosophy, right?
Yeah.
Everything that can be managed, let it be managed.
Yeah. So now let's talk a bit about Epsagon. So what Epsagon does, Gal?
So basically, Epsagon is a monitoring company that our entire goal is to help you understand and monitor your serverless application. So the first thing we do is we automate this distributed tracing process end to end. You can visualize your entire application, understand every single transaction in it just by using Epsagon.
So I think that the main thing that I would like to focus is that Epsagon gives you the distributed tracing technique that we saw before, but in an automated way. So even if, for example, we can see a Lambda push a message to an SNS, which triggers another Lambda, I want to see it in the same place rather than two different traces. Also, the automated instrumentation is very important because, as we saw in open tracing, you don't want to manually instrument each and every event or each and every invocation. You want it out of the box working. Now, in serverless, more than more than ever, you want to focus on your application layer or the business layer, because the application is your business, and you want to monitor these KPIs, how long it takes for me to sign up a new user to the website or user purchase something and so on. These are the KPIs that I want to monitor. And soon we'll see that it also provides visual debugging and cost tracking as part of our performance monitoring. Now let's talk a bit about our AWS partnership, because we're working closely with AWS. We are an advanced technology partner. We've got the DevOps competency. We're also listed on the marketplace and the solution space. And we've also been partners in the recent Lambda layers announcement that took place in reInvent. Now, how do we approach the world of monitoring this, whole composition?
So basically, we see monitoring as a pyramid, right? Where unlike the orthodox systems where the pyramid was upside down, right? Like monitoring the function and the system was the most important thing. Now the pyramid has shifted. Monitoring the function stats it's important. I'm not saying it's not important.
But just the first step.
It won't help you understand everything. It basically will only help you understand the most basic things about your application. The next things you want to monitor is the transactions, right? Those events that are flowing through your system end to end, and understand that when an error occurs, you can perform root cause analysis just by knowing, okay, if this Lambda has an error, I know every Lambda that is connected to this specific execution, or every resource is connected to this specific execution.
Yeah. Also, on top of that, sometimes you want to monitor an aggregation of transactions, which are your business flows. As we said before, when user registers to your website, sign up, or registers, or user buys something or do something. So these are data flows. It means how data flowing through your system. And on top of that, we can provide KPIs. And the last one is obviously the architecture, because sometimes you just want to see in a glance, how does my architecture look like? Where are the errors? What is the performance of each and every resource? And let's dive a bit into each one of them. So for functions, as we said, it's the first part of monitoring. It's each and every individual resource. And functions are great because on each one of them, you can detect errors, you can detect timeouts and out of memories, which is the specific issues that we found out on serverless. And also you can monitor the cost of each and every function, because if the performance is going bad, so you'll pay more for it. Now, how transactions goes like?
Now, as we said, transactions are the perfect tool for root cause analysis, because understanding errors in a specific function is fine, but when a customer is complaining that something isn't working, you want to have a look at the error and understand immediately what is the root cause of it, where the root cause doesn't have to be in the same execution. And this is where transactions are coming for the rescue.
Yeah, and on top of that, data flows, as we said, great for monitoring business KPIs and SLAs. I mean, how long it takes for user to sign up for something or to buy something in our system. It's very crucial because
not just monitoring, but optimization, right?
Yeah,
because you want to understand where are your pain points and where are your bottlenecks in order to improve them.
Exactly. In each and every data flow, it's very interesting to understand where is the bottleneck, where can I improve the overall performance of my application. And on top of that, as we said, architectures are great because you want to track everything in one place and see all of your resources. And also, I can say architectures are dynamic. I mean, you're sketching up, I don't know, 6 months ago something on your board, and 6 months afterwards it doesn't look the same. All resources have changed, and you want to have something on top of that you'll make sure.
I think the fun thing about this way we look at things is that you can either do a drill down, like look at the architecture, see what is okay, what is wrong, look at the specific data flows, then look at the transactions that are erroring out, then look at the functions, or you can do it from the bottom up. Like I have a function error, let's do a root cause analysis. How many people does it affect? Let's look at the data flow. That's the kind of thing that I think is really cool about this way of looking at things.
Yeah, so let's stop talking and let's get going. We'll start with the setup, how you get going with Epsagon. The first part is to deploy CloudFormation. This CloudFormation stack allows us to read list of functions and read your logs in order to understand all of the invocations and all the resources that you're using as part of your serverless application. And it allows us to build you a nice picture of all of your functions and their current status and performance issues. And the second part is the instrumentation, where you install the Epsagon library on your code, currently supported Java, Go, Python, and Node. This example is in Node, by the way. You can see how pretty simple is that, and no code change required. You just require the library, you initialize it with the token that you're getting and giving your new application a name, and then just wrap the Lambda function where all the code remains the same.
Another cool thing is that if you're using serverless framework, then we have a plugin where you can just plug and play Epsagon, and there's literally zero code change. Same thing with Pulumi, I think.
Yeah.
Also, we have a layer, so you can just install a layer instead of changing your code, and that means there's literally zero code change if you use our layer.
Okay, so without further ado, let's show some demo cases where we actually troubleshooting something in real. So this is the Epsagon dashboard. In the Epsagon dashboard, which by the way, it's on demo.epsagon.com, so feel free to reach that demo environment. It's really nice. You'll be able to see everything that we're just covering over here. You'll be able to see the main dashboard, also the functions page, event search, data flows, architectures, and alerts. I really love to start with the functions because, as we said, this is the base component of serverless compute. And in functions, it's really interesting because you can see a list of all your functions. In this case, we're seeing all 30 of them. You can see them from multiple AWS accounts if you're utilizing one for production, one for dev, staging, and so on. And also every region and every runtime. So all of your functions are being covered in a single place. And also for each function, you can see the actual trigger because you know how many times you're thinking, wait, what is the trigger of my function? And here you can see it in a single place. For each and every function, you'll be able to see how many invocations, how many errors and timeouts and out of memories, all these issues that we've talked about before. So here are visible for you. And also, when was the last invocation to detect dead functions, the performance obviously, and the cost, which you know, sometimes it's really interesting to understand, wait, how much do I pay for a function? Is it more than $100? I should fix something, like it's probably performance.
I filter by this column on a daily basis, just to understand that everything's okay.
Exactly. Now let's dive into an error. I've sorted the table by errors, and now I want to troubleshoot, let's say, blog site app, prod, post analysis, which is one of my favorite functions. By the way, in this demo, we are covering a blog site application. It's a REST API of a blog site, which allows users to read posts and upload posts for the editors. And in here, we can see a nice overview of what happened in the last day for the function, including the invocations and errors, memory usage, and duration statistics. Here, it's really easy to find because it's on percentiles when something bad happens, even if it's a spike. So even for a 1% of the request, it took longer. We can understand and troubleshoot these specific issues if we're focusing on performance improvements. Now, below that, we'll be able to see all of our invocations. This invocations list includes each and every invocation that your function ran. And for each one of them, we'll be able to see the status, the memory usage, and the duration. And also, which one of the very important, the CloudWatch logs themselves. So let's assume I want to troubleshoot this specific issue. I'll go to the CloudWatch log. And you know, instead of digging through endless logs and trying to
log streams.
Yeah, log groups, log streams, and so on, just get me the logs. It's very easy. Now, sometimes logs are not enough. I mean, we see the problem, we see the traceback. This specific function is in Python, and we see the traceback, but it doesn't got some context around here, and we want to dive in and really understand what happened. So in this case, I would like even to go backwards and let's say pick an error that I know was a very problematic and see much more than that. So if my function is instrumented using the Epsagon SDK, we'll be able to see the full context. And we see that for this invocation, for the post analysis below here, we'll be able to see the exception that we just saw and also the logs. But sometimes I just want to understand the real context or how to debug it, like what went wrong, see the real root cause analysis. And I'll be able in such case to go backwards even to the SNS to see the payload message that went through. In our case, we see some weird behavior of user not authenticated over here. Yeah. And you know, if it was just a single trace, then I would have to go and find the relevant of what happened before that. But since Epsagon is doing distributed tracing, I can go even backwards and see what happened. So see which was the Lambda and the exact invocation that published that message to that SNS. See the CloudWatch logs over here. But also all of us can see that there has been some problem with Auth0 for authentication. So let me see what happened. I can see that it's 401 error, unauthorized error. But you know, now comes the fun part as a developer, or the opposite of fun part, where you haven't got the response body and you can't actually troubleshoot it because why the hell you got 401? Yeah. And in Epsagon, we got you all covered. We're tracking all this information all together, so we can see the response body and understand that there was a JWT expiration. So we can fix it very easily. And you know, we saw as in 10 seconds, we really understood the real root cause analysis of a problem. And it goes the same for each and every node. We'll be able to click and see the actual data that went from one point to another.
I think another cool thing about this is like, you know how when SNS a function fails and if the SNS is triggered and you have to and it retries and you're not sure if you're handling the retries correctly or not. So we're gonna show you every retry so you understand that there was a retry and whether you handled it correctly or not.
Exactly. That's correct. Most of the developers doesn't aware of this situation. Now in my application, sometimes I just want to search for some events that happened. In this case, I would like to search for a specific event, which for me is very interesting, which is the start execution operation. And let's filter it by start execution.
The start execution for step function.
Exactly. This is specifically for step function. For me, step functions are very interesting because troubleshooting them is even harder because something orchestrates everything and now I need to correlate logs between multiple places. So let's assume I want to take
By the way, that's really annoying. That's in AWS, you can't jump to the specific execution of the Lambda, right?
I know. It's
step function.
I know, it's very hard. But in this specific case, we'll be able to see a cron job triggering a Lambda, which initiates this step machine. And then we'll be able to see the all flow of the step function, including the ingest processing that takes files from S3, the analysis Lambda function, and then the last step of storing the processed items in an S3.
And so this is all specific executions of Lambda function, not just...
Exactly, it's not random. They're all connected to each other because we're doing this distributed tracing. Now let's jump to data flows. Data flows are, for me, I think, one of the most interesting parts at Epsagon because we said that you want to monitor your application and your business KPIs and SLAs. So Epsagon automatically detects all kinds of flows that it detects in your systems. And initially it gives a name which can be meaningful, but sometimes you want to rename it to something more meaningful for you. For example, the post analysis. Post analysis happens when new editor uploads a post to our blog site and it starts some chain of analysis including many resources, and I want to understand how many times it happens, how many errors, what is the performance in percentile.
How long does it take?
Yeah, exactly. And now I don't just want to see that, I want to see a breakdown of each and every operation that happened in this data flow. So first of all, let me show you this data flow, which involves API gateway, Lambda function, Auth0, S3, Lambda, DynamoDB, another Lambda, Kinesis, and another Lambda. And now, when I want to monitor the performance of a real end-to-end data flow such as this, I will be able to do it by see each and every operation and detect where are my bottlenecks. In this case, we can see that Auth0 usually takes a nice amount of time, like almost 400 milliseconds. And as we talked before, reducing it improves the performance, but also improves our cost. Like it's reduced our cost by the end of the month.
75% of our time is spent on calling it Auth0.
Exactly. So, by the way, in such case, it's very useful to do some caching or maybe switch to another service which the performance
or a region that is closer to Auth0 servers.
Exactly. Now let's jump to the architecture screen. The architecture screen shows you in one place everything in your architecture, including the status. So here we can see all of our resources from all of the transactions automatically generated and dynamically updated. So you'll be able to keep track of what's going on in your architecture in production or in development or in staging and so on. Last thing I would like to mention is also the alerts. So the alerts are configurable by any type of alert. For example, timeout, out of memory, code exception. I will be able to filter this alert by specific functions that I would like to, or maybe a specific application that I want to, or even production or staging that I want to monitor, and stream them to Slack alerts or as email or webhook if I want to customize something of my own. Now the last part at Epsagon, and I think it's very interesting, is the dashboard. Well, the dashboard gives you in an overall overview what's going on in your architecture, starting from the system health, cold starts, monthly cost, estimated cost, obviously, and invocations and errors. But insights, I think, are the most interesting part. Maybe you'll be able to elaborate on them.
So I think what is cool about insights is that we don't just show you the errors in your system, but we're gonna show you errors that are almost happening in your system. So if you have a function that is close to a timeout or a function that is close to a memory, out of memory, you don't want to hit the timeout. You don't want to hit it out of memory. You want to be alert before that. There's other custom insights that we're working on and that we're making, and the entire point of them is let you know that an error is going to occur or there is something wrong with your architecture without an error actually occurring or affecting your users.
Yeah, ultimately give you, the users and the developers, actionable items to work on rather than just exploring the next issue.
Yeah.
So this was the Epsagon demo. Feel free to reach to demo.epsagon.com to see that in live. And now you know what, Gal, when is the best time to use Epsagon? When is the cue that you know you need for something better than, I don't know, just looking at logs?
So I think that there are several key signals that's going to give you a hint that you should look for a better monitoring tool.
Yeah.
So if you're looking at the bazillion logs, trying to find your way through the log streams, starting to say, all right, so this function failed, what triggered it, go to the next log stream and the next log stream, that's a good sign that you need a distributed tracing system.
Yeah, because you got no context and you just can't troubleshoot out of the blue some things.
Also, the more moving pieces you have, like the more resources you use, the more Lambda functions you have, the more DynamoDB tables, the more S3 buckets. Basically, the more moving parts in your system, the more you're going to need a solution like Epsagon.
This is actually where distributed tracing comes in part to match all of this together in single place.
Now also, if you there's no way for you to be alerted for issues that are specific to serverless environments, right? Like for if your function are timing out or they're having out of memory. If you're not sure if today in your system there are timeouts or out of memory that you might not be aware of, this would be a good time to try out Epsagon.
Correct.
And also, if you want to track your costs, right? So if you're at the start of the billing cycle and you're not sure what the cost is going to be at the end of the month, that would be a good sign that you can use a tool like Epsagon to help you figure that out.
Yeah, exactly. So it's been a real pleasure to host you all in our webinar of monitoring serverless application in practice. We introduced some of the best practices out there, how to monitor and troubleshoot your applications. We presented everything on our demo, so feel free to reach our demo. We also got free trial and free tier for you to get started with Epsagon. And we're available for any question that you have. We had a lot of fun.
Very responsive.
Very responsive. Thank you very much all.
Thank you guys.